Hello, my name is Gowtham Rao. I lead the OHDSI Phenotype Development Evaluation workgroup. Together with Asa Shaibi, we host this workgroup twice a month on the second and the fourth Friday from 10 a.m. to 12 p.m. We also have office hours that alternate with the workgroup meetings. So please join us. We collaboratively develop phenotypes. We work on best practices, and this is also the best time for us to learn as we walk this journey of phenotyping. So for this particular session, I wanted to talk about the OHDSI Phenotype February, to talk specifically on day number 14 on hypertension. So this particular post talks about certain best practices centered around what is called as a clinical description. So I'll go through this post really quick, and I'll encourage you to read it in detail. And if you have any questions or concerns, please come to the work group and we'll answer it for you. Um, so very quickly, this topic is hypertension. Hypertension was voted by the OHDSI community and was chosen as one of the cohort definition, one of the phenotypes to work on as part of Phenotype February. So the first essential step that we advocate for is to develop a shared clinical understanding of the phenotype. So hypertension is a pretty common phenotype. So there are several authoritative consensus documents out there for hypertension. One good source is a textbook of medicine, say Harrison's Manual of Medicine. So to start this work, I first found the chapter on hypertension and read about it. The material that we want for the initial review, we expect it to be at a certain level. We think the way I describe it is that it's at the level of a fourth-year medical student or a junior physician or a mid-level provider like a nurse practitioner or a pharmacist. If it is that material is considered patient education material, then it's likely to be at a much lower level than what is needed for phenotyping. Or if it's at a much higher level that only a specialist in the field can understand, then it's probably a very detailed for a phenotyper. So my general first practice is to take my own notes. So I read the chapter and I make notes on all what things that I found. So this is my notes and I post it out there. I then look at some clinical vignettes. Clinical vignettes are very good to understand the treating physician's perspective, treating clinician's perspective, and also the perspective of the patient. So here's a case of Mary. Mary is 38 years old. She was going for a routine appointment for contraception use. She does not smoke. She drinks occasional alcohol, and her blood pressure was found to be on the higher side. They measured the ambulatory blood pressure measurement for Mary, and it was found to be averaging on the higher side too. So she was diagnosed with stage 1 hypertension and then managed appropriately. So this helps me understand what stage 1 hypertension is. This is another case of Danny. He's a 39-year-old gentleman who smokes, has alcohol consumption. He's coming for a sore ankle. So during the assessment, he was found to have high blood pressure on the left arm. Second measurement of the right arm was also high. The third measurement was also high, and he was subsequently managed for essential hypertension. This is an example of an 81-year-old female who's a non-smoker. She was found to have a stage 2 hypertension about a month ago, and now is coming for a follow-up visit. So these are examples of clinical vignettes that I like to start with. The most important first step before any phenotyping is definitely to write a clinical description. This is the place that I spend most amount of my time. This is because if we need to identify a set of people and then evaluate if the people that we have identified from the database data source truly meets the idea that we're trying to phenotyping, we best write it up front. Now, if we all don't have a shared understanding of what we are trying to phenotype, then we cannot evaluate if we are truly identifying the people we want to study. So, um, I describe this as the clinical descriptions of a group of persons. This is something that one clinician would use to talk to another clinician. It may be verbose, it may be semi-structured, and it's written in natural language. This is not a computer algorithm. It's definitely not diagnosis code. In fact, if you start thinking of a diagnosis code or how to implement this in Atlas at this stage, you're most definitely doing something wrong. So we would say stop, reset, and restart. Do not go and look at Atlas or code sets at this stage. You need to develop a shared understanding. Here's some examples from past work. The structure for vitiligo involves an overview, presentation, assessment, plan, and prognosis. Same with CLL, overview, presentation, assessment, plan, and prognosis. One of the main ideas here is if the clinicians in your team are not able to clearly write the clinical idea in this structure, then we most likely cannot identify these people in the database. So if the clinicians are not able to agree on clinical description, we cannot phenotype. That's an important consideration. So we have attempted to formalize the structure, and the formalized structure has the overview, presentation, assessment, plan, prognosis. The overview is the key summary of the phenotype that highlights salient features. Presentation is how the clinician first observes the phenotype in a person. And the assessment is what are the tests or the evaluation that is done to confirm the diagnosis, and the plan is the treatment that happens afterwards. Prognosis is an important attribute for clinical description. Prognosis tells us when does this clinical state end, or maybe it doesn't end like a chronic disease like diabetes. How does it progress? Does it get better? And so on. So prognosis is important because it helps us design cohort definitions appropriately. Here's my write-up on hypertension. So the artist community deliberated and voted on hypertension. But as I was reviewing the clinical textbooks and then the clinical vignettes and writing my own clinical description, I decided to rephrase it and call it essential hypertension. This was important because it clarified to me that this is different from secondary hypertension, malignant hypertension, and hypertensive emergency. In fact, it's not even treated hypertension, is how I define it. By describing this upfront and saying what it is and what it is not, I am clarifying the target. So the way I've written this up is for the overview section, we have persons newly diagnosed for the first time with chronic hypertension, not explained by secondary medical correctable causes, identified in an ambulatory or office setting as part of a routine asymptomatic or incidental primary care visit in persons who have had no significant past medical history, no evidence of damage. This is the section on assessment, plan, and prognosis. Next step is to do a literature review. Now, we want to build on other people's work. We don't want to start something from scratch. How have others tackled the problem of phenotyping and observational research? This is the first time I think we should start thinking about building concept sets and building cohort definition. We should not be working on tools like Atlas at this time, in my opinion. So we did a systematic literature search. I found a few articles that have used observational data to generate evidence on hypertension. There's an article on hypertension um, in the journal Hypertension that uses the ICD code 401.9. It did include malignant hypertension, which is not something of interest, which is not of interest to us, and also it includes hypertensive encephalopathy. Then we found another article on the American Journal of Hypertension that also focuses on hypertensive emergency. But for this, they use the AHRQ CCS software as a source of codes. There's another article on American Journal of Cardiology, which focuses on hospitalization in hypertensive emergencies. So on. So what I found in my literature search is there are several articles that were performed on observational data. They use various types of codes, but many were focused on severe forms of hypertension, like hypertensive emergency, hypertensive crisis, malignant hypertension, and very few were on essential hypertension. That was an aha moment for me because am I missing? Is my literature search not comprehensive enough? Have I done something wrong? Or is it true that nobody has actually studied this common disease idea called essential hypertension? Many have referenced the HRQCCS code, so I'll review those. There was the use of primary was a secondary diagnosis. And I also made a list of all the codes that were used by various previous work. One of the insights there was the pregnancy-related codes. I found that there were codes that were classified as hypertension or hypertension-related conditions that complicated pregnancy, childbirth, and puerperium to be included. So I thought to myself, is it appropriate or not? And finally, I came to the decision that although my clinical description did not have any information on pregnancy, if somebody is pregnant but had hypertension before, that hypertension was complicating pregnancy, that's fine, and we should include that. But if pregnancy was a complication of pregnancy, then that's not something we want to include. So I clarified the clinical description to made that change. So there's a pattern here. We start with an authoritative source. It's at the right level. We review clinical vignettes. We write a clinical description. The clinical description specifies the target. We can develop an acceptance criteria, and then we look at other people's work in observational research. Written a draft paper called The Science of Phenotyping. That's at the OHDSI Phenotype Development Evaluation workgroup. That's right here, and I'm going to try to give you some summaries of the ideas here. First step is how does OHDSI build a concept set expression? Concept set expression is like a formula. It tells you what codes to include, what codes to exclude. It also gives part of the formula says include this code and its descendants. When you execute that formula, it gives you a list of codes called the resolved concepts. That's your code list. So to build a concept set expression, the process we follow, and we can go into more detail in the work group, but very quickly, we start with a starter set. We resolve it and look at the codes. Look at the semantic meaning of every code and make a decision. Do we agree with it or we disagree? If we disagree, we either remove them and then we go through this iteration over and over again till we agree with almost all the codes. Then we use a tool called Phoebe. We take all the resolved concepts and give it to Phoebe and say, hey, Phoebe, give us some recommended codes. And that's an informatics solution. It will look at the strings of the words in the various concepts, then find recommenders. We can use that recommended to further iterate. And there's a lot of details here. There's several tutorials on Phoebe and on OHDSI. So for hypertension, I ended up with this concept set expression. It's a pretty complex concept set expression that has several codes that is included with its descendants, and then some are excluded. If I could call out here, I could exclude a secondary hypertension, pregnancy-induced hypertension, hypertensive crisis. Here I detail the logic, the process in which I went from a starter set, went through that iteration, and finally built out the final concept set expression. Then use that concept set expression to build cohorts. Those cohorts are in atlas-phenotype.odyssey.org, and here are the different core definitions that were used for the February 14th Phenotype February. Here I'm highlighting just three of them. These three of them have various rules. I'll pull one of them just to show you. So in this case, we have a condition occurrence of essential hypertension. Essential hypertension concept set expression is shown here. If I click on the included codes, it will show me the various codes that were included in this expression, including source codes that are ICD-9 and ICD-10. By the way, you can have access to it by going to OHDSI forms, and there is a request form there that you can go and request. This particular cohort definition, I've also done some exclusions. I've said a person should have no secondary hypertension, exactly zero occurrence of secondary hypertension, like renal hypertension, renovascular hypertension, and so on. No occurrence of hypertensive crisis, no pregnancy-induced hypertension, and no intermittent hypertension like labile hypertension, and so on. I ran that on Cohort Diagnostics, and that is available to you at data.odyssey.org/phenotype February. You can I reviewed the results of the Cohort Diagnostics, and I made an argument here about how the various cohort definitions perform. What's the sensitivity and specificity trade-off? My argument here was that I have three candidate cohort definitions. The one cohort definition is pretty broad. It starts at a hypertensive disorder. This one is my concept set expression of choice, which is essential hypertension. And here I have the same concept set expression, but I have additional exclusion criteria. My argument here is that across the three cohort definitions, I have reduction in counts. That's excluded. That's expected because I start with one that is broader and then I have more restrictive rules. But the counts don't drop much. They are 8.9 million, 8.6 million, 8.3 million. It's dropping by a few percentage. But when I look at the people that were removed, I see that they are significantly different. In fact, the people that were removed don't match my clinical description. That's a good thing, because now I can say that the people that were removed don't have essential hypertension. They may have some complications of hypertension, like malignant hypertension or secondary hypertension, but they're not essential hypertension. So the people who are left behind are more likely to have essential hypertension, so their specificity went up. So that's the argument here, that using cohort diagnostic and empirical approach, we built a cohort definition that are most likely has a good sensitivity and specificity. We're able to make an empirical argument for it. So please join us at the OHDSI Phenotype Development Evaluation workgroup, and we can continue the discussion. And we're looking forward to building more phenotypes together.